Okay. The quiz is short. It's just 1 page, 5 problems. So I figure we'll just spend a little bit of time just reviewing everything and making sure you're comfortable. And if you have last-minute questions, we can address that. I have 2 in-class review problems, but let me just run through a couple of things first. This is from the review worksheet from yesterday. If I want to convert from degrees to radians, I just multiply by pi over 180. If I want to go from radians to degrees, I'm going to multiply by 180 over pi, right? There was a question some one of the students was asking was, if something is in radians, does it have to have pi in it? And the answer to that question is, you're only going to have pi as part of your radian measure if you're actively converting from degrees to radians, or if something is already given to you as radians, or with that pi in it. So here, obviously, if I'm ever converting from degrees to radians, assuming that there wasn't a pi here, right, you're always going to involve times pi over 180. And so that's why pi is going to show up with radians. But that's not always the case. So for instance, if you look at number 3 here, arc length formula, right? S equals r theta. S is 15, that's arc length. R is 6, and it's asking for theta. If I solve for theta, I get 15 over 6, and we know that anything from that S equals r theta is going to be involving radians, right? So your theta is just 5/2 radians. There's no pi involved, so we never want to add pi just because we see radians, right? Only if you're actively converting from degrees to radians is that pi going to most likely show up. But we don't want to just go ahead and assume that there's a pi here. So if there's no pi in our algebraic steps, then we just have, that's our radian measure as it is, right? We don't want to make any adjustment that doesn't need any adjustment. Now, if I want to convert that radian measure to a degree measure, then I have to involve 180 over pi. And then pi technically does show up in our theta, but we can also, I'll ask you for nearest thousands. So you will just enter this in the calculator and get a decimal value, and that's your degree, right? So a lot of times pi does show up for radians, but only if it's showing up within your process, right? Don't just randomly attach pi just because you see radians. Okay, so that's one thing that I wanted to make sure I review over. And then the most complicated thing within this quiz is just dealing with the reference angles and all the steps involved. So let me go through those steps again, and then we'll practice 2 problems, make sure we're good, and then we'll take the quiz. So again, with reference angle, make sure that you're working towards getting to a coterminal angle, especially if the angle is not given to you in that easy range. So either add or subtract 2 pi or add or subtract 360 to get into this comfortable range where we can identify which quadrant we're dealing with. Okay, and once we get into that comfortable range, we're going to identify the quadrants of our location. If it's in degree form, students have a lot easier time because 0 to 90, anything between that is going to be first quadrant. Between 90 and 180 is second. Between 180 and 270 is third. Between 270 and 360 is fourth. But if it's in radian form, you have your calculator, so you can always check that decimal value in front and see what decimal value you get, right? If you get a decimal value between 0 and 0.5, then it's obviously quadrant 1. If that decimal value is between 0.5 and 1, then quadrant 2. If your decimal value is between 1 and 1.5, then quadrant 3. And anything between 1.5 and 2 is going to be fourth quadrant. Now, once you identify the quadrant, then that's going to help guide what you're going to be doing, because you're always going to be subtracting or adding subtracting involving your 180 degree, your x-axis, whether it's 180 degree pi or 360 or 2 pi. Okay, you're never going to involve 90 or 270 when you're doing reference angles. Okay, so even if your angle is closer to 270 or closer to 90, we always want to just involve the x-axis. Okay, so if you're quadrant 1, you're good. There's nothing that needs to be done. You already have a reference angle that's in the proper range. If you're in quadrant 2, then you're going to do 180 minus theta minus your angle, because you want to make sure you have a positive number. So you're always going to be the larger minus the smaller. Okay, if you're quadrant 3, then you're going to take the larger minus smaller. So your angle measure minus 180 or your angle measure minus pi. And if you're in the 4th quadrant, either 360 minus that theta, that angle measure, or 2 pi minus that angle measure. Okay. Any questions for that process? Okay, so let's just do 2 quick problems here before you guys take your quiz. So go ahead and get out a sheet of paper and let's just try these 2. Right? Let's make sure we're on the right page, that we're comfortable, and then. Okay. You guys can use your calculators on the quiz. First things first, we got to deal with that negative 448, right? It's not easy to tell what quadrant that is. So we're going to keep adding 360 until we get to a coterminal angle that's the same, but easier to recognize, right? We want something that is comfortably between 0 and 360. That way we can nail down the quadrant that we're working with. So which quadrant is this angle going to be in? 4th, good. Okay, the reason that we know it's in the 4th quadrant is because we can add 360, which is negative 88. Now we want to just drop that negative and just look at that 88. That negative 88 is still not in the proper interval. So you're going to add 360 again. Okay, add 360 again. 272. That is slightly more than 270, right? 270 is that y-axis separating the 2nd and 3rd quadrant. So we know that's going to be to the right of 270. That's in the 4th quadrant. And if something's in the 4th quadrant, we have to involve 360, right? Don't do 272 minus 270. We're always involving the closest x-axis. Our theta prime represents our reference angle. 360 minus 272, 88 degrees. Let's double check. Is that reference angle positive? It is. Is it between 0 and 90? It is. So that's our theta prime.
Theta prime your reference angle? Or
that's right. Theta prime is your reference angle. Theta is your starting angle measure. Theta prime is your reference angle. Okay. Everybody okay with part A? Okay. All right. Try part B. So if I'm asking for reference angle, if I give you degrees, then you're gonna give me a reference angle in terms of degrees. If I give you something in terms of radians, then you're gonna provide your reference angle for radians.
Sorry, it's just the ingredient form.
Yeah, this is the in radian form. Okay, so 38/7, you know that is greater than 2. So we got to subtract 2 pi to get it into that range between 0 and 2 pi. So subtract 2 pi. And in your calculator, you're only dealing with a fractional value, right? You're just dropping the pi out of your calculator and just worrying about okay, so when I subtract 2 pi, I got 24/7, which is still greater than 2. So I got to subtract again. It's rotated multiple times around the circle. So I want to kind of unwind it until I get something that's more recognizable. So I'm if I subtract 2 pi again, I get 10 pi/7. Now look at that fraction. What's that fraction? What's it between? Which quadrant are we in?
Quadrant three.
Quadrant 3. The reason that we know that is because you can use your calculator, do 10/7, get the decimal value 1.43. 1.43 is less than 1.5, but greater than 1. So that's clearly in the third quadrant. If you know that in your third quadrant, you're going to be working with your closest x-axis. You're going to be working with the 180-degree line, which in this case is pi. So you'll do subtract the angle and pi. And the reason that we know that it's 10 pi/7 minus pi and not the other way around is because we always do larger minus smaller. If we do larger minus smaller, you can always guarantee to have a positive number in return. Double check 3/7 is that fraction between 0 and 1/2 or 0 and 0.5. It is. So we know that's a clean reference angle.
Yeah, you put 3 pi/7.
That's fine. 3 pi/7, 3/7 pi. Yeah, that pi can either live outside or with the numerator. Okay, questions? All right, make sure your phones are up. Book bags, make sure you zip up your book bag all the way. You can have your calculator out. Oh, today is the 19th. I know I have some new students in the class, so want to make sure. So if you guys look up here, there's a little folder here, and the folder will be right under your calculator. You can, once you turn in your quiz, you can grab your sorry, underneath your phone. So once you turn in your quiz, you can grab your phone. If you need more space, you can use the back for scratch sheet or work out any problem. Just make sure you indicate to me that you're doing work on the back if you're doing that. So that's, yeah.